Hi, class. Wanted to take some time out in Unit 4 to go over maybe about 5 problems that can using the viewing example that can give you some kind of help to with your homework, your test review, and your test. So this is the first problem. I'm going to use the viewing example to kind of as a guide so you can kind of see. So we have a tower that weighs 70 metric tons and is leaning. The angle of the tower with the ground was increased by 1.1 degrees. So now we the tower 47 point meters at the base, so this part here, and then we have the point of the directly above the point of the ground. So this little part here is 4.45. We want the question is how much did the point of the ground move towards the point base. So we begin off kind of understanding what is the information that we're given in this problem. The angle that we're talking about is this little tiny angle here, the point of the angle here. We know this is a 90-degree angle on this side, and down here will be the angle that we're actually going to be discussing. So for this one here, we go back to our SOHCAHTOA. We're going to use cosine because the adjacent, which we have down here, and the given hypotenuse that we have here, because again, remember this is our right angle. So this would be our hypotenuse. This would be our adjacent part. So the only thing we can use is cosine for this part here. So we put in our adjacent side and then our hypotenuse. And remember, if we're trying to find the angle, you always have to use the inverse button. Anytime we're trying to find an angle of something and we have the two, say we have two sides and the only thing was missing was the angle, got to put the inverse. So hit second and then inverse in your calculator. Then we're going to add the 1.1 degrees. That's what's increased, because increased meaning we're going to add. If it decreased, we'll subtract. So this here, we're going to increase it by 1.1. Now you can get your answer or you can kind of leave it in this format because whatever works best, because there's more to this problem that you're going to put in your calculator. So now we're going to figure out the unknown side of the beta, which is our new angle that we're trying to find because it moved or increased. So we're going to still use the same hypotenuse. It's just, again, since it moved a little bit over here, we're going to have a new length that we need to find. So to do the math after you're trying to find this C here, if this is on the bottom, you just take this one here, multiply by both sides of the problem, 47.9 over here, so that way these two would cancel. What you do to this side of the equal sign, you have to do to the other side. So you take this 47.9 and multiply it by the cosine B over here. So now that we have what we discovered in our first part of the problem times the 47.9 part in this problem, and then we're going to take the cosine in at the end. So this is what we type in our calculator: cosine parentheses cosine of negative inverse of our two parts that we found in the first part plus the increase times 47.9, and we get 3.53. Then we're going to take this angle, this little length here, subtract it to what we found here, and that gives us the point of the ground moved approximately 0.92 towards the base point. So we take this one here, subtract it from here, and we get our answer, our final answer of 0.92. So take a few minutes and maybe you want to just kind of practice putting this in your calculator and problems so you can have a good understanding come quiz and test time for this particular problem. The next one here, again, you're just trying to, the best way to do these problems is you have to kind of set up a picture. Once you set up the picture, then you kind of know what you're going to be using, sine, cosine, or tangent for the problem. So the headlights of an automobile are set as such as far as the beam drops 5 inches for each 30 foot of the car in front of the car. So here's the beam. down here from this town to the road is 5 inches, and it shoots a light out, and we're trying to find out this angle over here, because the light extends all the way out 30 feet. So looking at this one here, kind of guess of what we're going to be using. Sine, Saka, cosine, ka, or toa for tangent. The best way again to figure out which we're going to be using is figure out what the information we're given. If this is the angle we're trying to discuss, when you make your picture and draw your diagram the best way that you can, if this is the angle we're trying to discuss, the two things that we have for this problem is we have the opposite and we have down here is adjacent. We don't have anything to do with the hypotenuse. So if I'm already discovering that I don't need the hypotenuse, I can get rid of the sine and cosine because they have the h in it for Sakatoa, Saka. So we're just going to be using tangent because we have the opposite and the adjacent for this part. So we put this in here. Remember, if we're trying to find the angle, again, you always use the inverse feature on the calculator to get our angle, and we should get 0.8 degrees. Again, here's the problem. Draw your picture the best way you can. For this one here, what are we going to be using? Kind of answer yourself right now. What are we going to be using with this one? What two things do we have in this problem as far as given? We have this angle, we have this side, and we got this side. So let's think about Sakatoa. Which ones are we going to which ones can we eliminate? It seems like we don't have anything to do with the adjacent. There's nothing to do with adjacent. So anything in Sakatoa, if it has an A in it, go ahead and just mark it off your paper because we're not using that. The only one that does not have anything to do with adjacent is sine, because sine deals with opposite over hypotenuse. So here's my angle, the opposite on top, hypotenuse is the C that we're looking for. A little shortcut again, anytime the C or the X that you're looking for is on the bottom here, and we need to solve for it, we're just basically taking the whatever's on the numerator, 4.51, and dividing it by sine of this degree. So you divide. If your unknown is down here, just take these two up here and divide. So here's what to look at. The unknown is down here. We're just going to take whatever here and just divide those two to get our feet. So again, here's the problem here. You can read it for yourself. Again, draw a picture to kind of set up what kind of right triangle we're going to be working with. Once you have the right triangle, think about Sakatoa again, the two information that's given to us and what we're going to need. This one here, I don't need anything to do with the hypotenuse. So mark out your H's in Sakatoa. So if I don't need an H, mark it out. The only one that does not have that uses the H is tangent, because tangent is opposite over the adjacent. So again, the B is located on the bottom, just like we discussed before. The little shortcut is just take the numerator divided by this part here, and that gives you your answer of what's missing. The last one is pretty tricky. Cosecant. Anytime you're doing cosecant, you have to do 1 over something. So cosecant is associated with sine. And because we're doing cosecant, you have to do 1 over sine. If you do cotangent, if this was a cotangent, you do 1 over tangent. So make sure you make another note or like a little flashcard or a note card of what goes with what. Cosecant goes with sine, cotangent goes with tangent, and secant goes with cosine. So the first thing we're going to do is we're going to take the I kind of flip it or take the inverse of this part here because we have to kind of solve for here. I'll kind of work it out so you can kind of see the background parts as far as how that kind of works. So this is the problem that's given to us. We have cosecant of theta is equal to 4.74 7. So remember what this cosecant represents. It represents 1 over sine. And so the background kind of part of to how to do this problem here is we're going to get rid of the fraction by multiplying it by sine theta on both sides. So sine theta. That way this one cancels out with this one. So over here we're just left with 1, and then we have these multiplied together. I'm gonna just it doesn't really matter. You can just leave it like it is. 4.747 times sine theta. So now I'm going to get sine by itself. So I'm going to divide both sides by 4.77. That way, this part here cancels out. So we have what's left over here is equal to sine theta 1.4741. So you can leave it as a fraction, or you can go ahead and put this in your calculator. And once you put that in your calculator, you get 0.2107. You can go ahead and put it in there now if you want to, just to verify for yourself. So that's why they have the sine left by itself, and then we have 0.2107 on this side. Now we're trying to find the angle again, so we're going to take the inverse of both sides of the sine. Once we do that, we get 12.16. I think for this one here, we want to round to 4 significant digits. The reason why we're running a 4 significant digits in this problem here is because of what the answer is. We have to look up here and figure out how many significant digits is this? 1, 2, 3, 4. This given part is in 4 significant digits, so our answer needs to be in 4 significant digits. All right, so I hope that helps with these 5 problems. Review it, practice it. Go back, review this video again so you can be prepared for Unit 4 quiz or test.